So our speaker tonight, Matt, is committed to helping people achieve greater things. After over 3 decades of coding, Matt left active development to become an instructor at Tech Elevator, where he helps others understand the fundamentals of programming while holding on to the things that make programming fun. Matt writes software development at killalldefects.com and is building side.dev, a free online social project management application for individual developers pursuing side projects. So welcome back, Matt.
Thanks for having me. I trust you can see my screen okay. Let me know if you can't, and I'll kick it off here. So thanks again for having me. This is a talk I gave first a couple of years ago, back when I focused primarily on testability, software quality, and things like that. And this is really a lot of just takeaways from my time studying this very deeply in the .NET context. If you want to follow me, Twitter is usually the best way of doing that, though I'll accept LinkedIn requests if you tell me kind of how you found me, etc. But I'm at IntegerMan on Twitter. Some other things you should know about me: I'm down in the Columbus, Ohio area. I have a wonderful wife and a cute but noisy terrier. Both are upstairs this evening. I also help organize the Central Ohio .NET developer group, and I'm an instructor at Tech Elevator. Briefly about my employer, because I love them and they love seeing me plug them briefly at user groups. We're a 14-week programming bootcamp teaching C# or Java. We teach really full stack development in those technologies. So ASP.NET for the .NET stack, SQL Server, SQL, things like that. We teach REST and APIs very heavily, as well as front-end frameworks through Vue.js. We also teach a lot of soft skills and testing, security, and agile software development. When I'm not teaching, I'm often doing very nerdy things. So my hobbies often include game development, just for fun, writing on software, specifically a lot of .NET and Azure related things. I'm finishing up the first draft of a book on application scalability. If you're curious about that, ask me later and I'll give you a link. But I generally try to do the nerdiest things I possibly can, and that's what I tend to enjoy. So as I mentioned, this is a talk I gave a couple years ago. This is really a very surface level overview of a lot of different concepts related to .NET testing and testability. So I want you to discover a couple new libraries. I want you to look at a couple new perspectives, particularly related to taking a large application that's hard to maintain and getting it under control, building a safety net for yourself, improving its testability, improving the quality and readability of your tests, refactoring that application and making it more and more maintainable over time, and then some tools to just expand the surface area that you test as you're testing. We will not be doing any live coding tonight, but I have a lot of code examples. Additionally, the slides for this are available online if you wanted to follow along or reference them later. I put the link in chat earlier, which I think you should have available to you if you're looking at it here. So our examples today are from a sample application I kind of cooked up a couple years ago, which is a resume processing application. So imagine you have an organization that handles a lot of applicants. You get a lot of resumes in, and you want to see which of these applicants you want to talk to. So you upload a Word or a PDF or a rich text or markdown file or something like that, and the system will assign some sort of a numeric score based on how interesting this candidate likely is to talk to. And so you can filter down 100 candidates for a position to 20 in an kind of an automated manner. So it's a fake system, didn't actually build it, but it's an interesting backdrop for a lot of these things. I was looking over the code for this talk because I've not given it in a while, and I was struck by how egotistical some of the code examples are. So apologies for that, because apparently past Matt was a little full of himself, but we'll have a laugh at my expense for that. So I don't know if you've ever been in this situation before, but you will often inherit projects from other people in the workplace. And I've been in the position where I've inherited a legacy system that had, over 50,000 lines of code and 0 passing unit tests, and that was normal. It's not a fun place to be. And as soon as you get that, usually the first thing that happens is someone says, "Oh, by the way, we want this one thing." So if you have some application you don't fully understand, you haven't written the code of, you don't like a lot of the practices of, what do you do? And that's kind of what I'm going to be talking about tonight. So the way I see it, you have a few choices. Choice number one is, you could quit. You could leave, go find somewhere else that presumably has better code. In my experience, everybody's got legacy code. It's just a flavor of what flavor of legacy code you want. Second choice is you can stay, you can try to fix it, and failure is always an option. And I have failed before myself, sometimes drastically. It's never fun. And even if you don't fail or get to what you might consider a failure, you could get so stressed out that you're just not fun to be around, and eventually you just burn out and you quit or are quitted anyway. Thankfully, there is an alternative to all four of these, and that is to sort of build your own safety net. So as you're about to make your changes, you're going to make yourself a safety net so that you understand you might make some mistakes as you're changing things. You might not fully understand the requirements or the behavior of the existing system, but that's okay. You've got a safety net, and that safety net is typically unit tests. So unit tests exist to give us a bit more of a safety net as we're fixing our code, as we're changing our code, as we're adding new features. Unit tests exist to allow us to make mistakes and catch them before our customers have to catch them. They also will document our code. They will also just really help illustrate how to interact with the system to other developers who are taking over the project later on. So real quick, unit testing 101. This is a unit test. A unit test is a piece of code that tests other code. So it calls other code. So a test exists in some sort of a test class, and it is a method, right? And typically it's going to have some sort of an attribute on here. My examples here are all in XUnit, which is becoming more and more popular with the advent of .NET Core and beyond. So XUnit is often the standard that you'll see, but InUnit and MS Test both work very, very similarly. It's just different attributes. So we have some sort of a method, and a method is named something that represents a test that describes the behavior of the system. So if the test fails, you know pretty quickly what's going on. So in this case, if the resume processor looks at my resume and it doesn't score me well, this test will fail, and we'll see a report in some log somewhere. A test will usually follow a three-step approach, the AAA pattern: arrange, act, and assert. A test should test one specific thing. So that's the action it's going to take. In this case, we have a resume analyzer, and we're analyzing a resume, and we're getting a result of that, and then we're going to be doing some assertions. So we're saying, hey, when I analyze a resume, I want to make sure that the score of that resume is equal to a specific value. And again, past Matt was a little humble here, apparently. So this act should always be one line, is my advice here. On assert, you can have a few different tests that all sort of describe what the behavior you're trying to encourage or verify. And the arrange step is all about setting things up for your test. It should be as minimal as possible, as easy to read as possible, but this is just the things you need to do in order to do the actions or possibly some asserts. So that's unit testing at a very high level. And either you run this test as a developer using Visual Studio's testing tools, or your automated build pipeline will run the test later and tell you, like, hey, I can't let you merge this change, the tests don't pass. Along with testing, you'll often hear the term test-driven development, sometimes called red-green refactor. With test-driven development, or TDD, we start out with a requirement. Somebody says, hey, Matt, this is broken, or hey, I need you to add this new feature. The first thing we do is we write a test. We don't write the feature under test-driven development, we write a test, and this test should verify the behavior of the system in a fixed or completed state. So if I have a bug, the test is going to verify that a correct result occurs, and the test should fail because the bug still exists, right? So as soon as you get a failing test, your test is considered red, and now you go on and you make it green. You write enough code to make the test pass, and presumably all your other tests are passing too. And once you're satisfied that the tests are passing, you go on and you refactor. Refactoring means to change the structure or shape of your code without changing its overall behavior. So it's still doing the same thing, it's just easier to maintain, easier to read. And then you go back to the beginning. You say, hey, okay, I now have a passing test. Do I need more tests for what I'm trying to do here? And you keep going through this loop until you're satisfied that you've tested the feature that you're adding. It's fully complete, the bug is fully fixed, and you move it off into QA. And then you pull the next feature you're working on, and you go through the same loop. The benefits of TDD are that you have a lot of, you're guaranteed to be writing tests as you go. You have a lot of tests as a result over time, right? So I have tests that cover the commonly modified areas of my system, even if I started with 0 tests at all, which is cool. Downsides is some things are not easily testable. And in fact, you hear a lot of excuses from developers. Trust me, I used to be a manager. And it might be, hey, I can't test my code because I don't have time. It might be, I can't test my code because it's heavily reliant on the database, or it's heavily reliant on the user interface. And there's answers to all of these things, but people often have reasons why they can't test. And we'll take a look at some of the common objections to testing as we go along today, and some solutions to those things. One of the main reasons that people can't test is because their application is what we would affectionately call a big ball of mud. And this is a big ball of mud is a nice little term that refers to an architectural diagram where you have a lot of boxes and arrows, and it is illustrating how things are are related to each other. And this is a screenshot I found on the internet just doing a quick search. And it wasn't until I zoomed in and practiced this talk that I realized it was actually a .NET project. It's in Hibernate. So hopefully it no longer looks like this, but systems like this are very hard to test. They're very hard to maintain because everything depends on everything else. And modifying one thing without breaking other things becomes just exponentially harder. So today I'm talking about just how do we tame that? Like what processes do we go through? The steps that I like to follow are to build a safety net for myself in the form of unit tests and to kind of verify the existing behavior, to improve the testability of the application to allow me to write more and more tests as time goes on, to progressively improve the quality of those tests and the readability of them, to refactor the code and to make it suck less, to reduce our odds of shooting ourselves in the foot going forward, and to expand the surface area that we're testing just over time. And I'll talk about each one of these areas section by section as we go through the rest of this talk. So let's start with building a safety net. So there's a concept that I ran across. I can't remember where I ran across it. It's a concept of a pinning test. And this is a test to pin the current behavior of a system in place. You're trying to make sure that you're not trying to test one specific thing. You're trying to capture the existing behavior and state of an application in its current form as you start making changes to it. So if there's any change in the behavior of the system, you want to be alerted of it. One library I think that does that really well in the JavaScript world is a library called Jest. And Jest has something called snapshot tests. And with Jest, it says, hey, I'm going to serialize an object to JSON, and I'm going to compare it to the result later on. And if it changed, the test is going to fail, and it's going to tell me exactly what's different. Really kind of a broad shotgun approach to testing. But there is a library for that in .NET. It's called Snapper, short for snapshotter, I'm sure. With Snapper, you have a new extension method on anything really that's called should match snapshot. And should match snapshot checks against a JSON file. And it says, hey, if this differs at all from the JSON file, I'm going to fail the test and I'm going to tell you how it was different. You generate that snapshot by adding an update snapshots attribute to your test method. Now you have to manually add this attribute whenever you want the JSON file to be generated for the first time or updated. And then you remove it or you comment it out like I have here, and you run your tests again, and you commit the JSON file to source control. And then when anybody else runs your application, it's going to verify that. It's going to serialize the current state of the object, and it's going to compare it to the snapshot, and it's going to fail if they don't match. This is again a shotgun style approach to testing where you're just having a very broad range of things that you're testing. You're not even really being explicit about what you're testing. But if something ever changes as a result of something, you're going to know about it. This is really good for upfront if you don't have a lot of test coverage, but you want to stop relying on this over time and eventually even remove these tests as you get more and more specific tests over time, but it's really good to have kind of a broad coverage up front. I like Jest a lot better than I like Snapper, just because Jest will auto-generate it for the first time, whereas Snapper you have to have this attribute on. But it's possible that they've improved the library since I last checked. Kind of a related concept is a library called, a tool called Fiddler from Telerik or Progress. Now they're called, their parent is. And Fiddler is an application that you install on your machine, and it intercepts outgoing web traffic, and it will record it. So it's kind of like your network tab in your browser, but for your entire desktop. This is really good for if you're running a server on your local host, or if you're running some sort of a desktop application or a console app, Windows service, something like that, that might do a lot of external API calls. Fiddler will let you capture that information, see what kind of requests you're making, what kind of responses you're getting, what order they're coming in. It really is good for helping understand the behavior of an application you're taking over. I believe it has some automatic verification and simulation features. I haven't played with those, but I believe it may have them by this point. But it's very good just for understanding and debugging web service calls. So I do like that quite a bit. It's not really one for automated quality assurance though. Another tool related one is the tool of Postman, which I hope most people are familiar, at least vaguely, with Postman. But Postman allows you to make API calls and see the responses that come back. It's very good for doing API development and testing and things like that. But Postman has a lot of hidden bells and whistles. It actually has some variable support and things like that. And you can even record requests and responses, upload them out there to their cloud, and they will make a set of calls that you ask them to make to specific URLs, and they'll let you do things like verifying you get back a 200, or the response should contain a specific string, or it should occur within 500 milliseconds, or something like that. This is really good for a quality assurance type of person who is who's trying to write tests that cover their application, but they don't know how to write code yet. I've actually used Postman collections to monitor staging and testing environments, which DevOps promised me would be operational most of the time. But if those are down, I needed to know pretty quickly before somebody else found it and started asking me what's going on. But you can actually get emails on failures, which is really, really cool. So that's a nice little tool you have. And they do have paid tiers and free tiers, and the free tier is good for low volume. Another thing you can do to verify functionality at the user interface level is Selenium WebDriver tests. So this Selenium lets you do basically browser calls. It lets you navigate to a URL and verify the result. It uses something called the Chrome driver, which is a headless version of Chrome. Doesn't show any sort of user interface to anybody, but it makes the requests and it takes a look at the responses, and it otherwise behaves like a web browser. And you tell Selenium, you say like, hey, I want you to navigate to a specific URL, and then I'm going to have you query the page and find something by its ID or some CSS selector or something like that, and you can verify it. By the way, this test here goes out to isitfriday.org, and it verifies that the big label on the page says no. This test always passes for me. I've never encountered any issues for it, but I typically run it on Thursdays, so you never know. A little bit of a programmer joke there. So let's move on a little bit to talking about improving the testability of our application, because that's kind of a common concern that we have. So I do ask you to mute if you can, just for our benefit here. But one of the common issues that we have with tests is that it's hard to test things that are dependent on the database, right? So imagine our resume processing application has a database full of keywords, and say, hey, whenever you see testing in somebody's resume, give it a 5-point bonus, X unit, N unit. Those things get a little bit of a boost. MS test, maybe not as good. We'll give it a 2-pointer though. You see PHP, maybe dock 10 points from the resume. I kid. Apologies if anybody does PHP. But you can easily imagine code in your resume processing application that might look something like this. It goes out, it connects to the database and it queries a set of these modifiers and it returns some sort of a dictionary. What the code's doing here isn't actually that important. The important factor is that your code is now reliant on the database to be present in order to work properly. Well, that's fine if you're trying to test the database connection, but if you're just trying to test that the behavior of some other methods, well, now your code is a lot slower because it's got to talk to the database. Your code might fail if the database becomes offline, which can happen if you're running like a nightly build or something like that, because often databases go offline after hours. So one of the things we can do is we can sort of decouple our application from the database as much as possible. And the way we do this is typically by introducing some sort of an interface. So we might introduce an I keyword bonus provider interface that just returns a dictionary of keywords and scores for those keywords. We have a load keyword bonuses method on this interface, and then anything that meets this signature can serve our application's needs, right? So our method just takes in something that provides keywords. It doesn't need to know where those keywords came from. It could come from a database, it could come from an external API, from a file, it could come from user input or some fake data for testing purposes, right? So that's sort of what we have there. So you want to make a pretty liberal use of interfaces as far as encouraging testability goes. So let's talk a little bit about what this might look like if you're trying to provide a testing alternative to a database, right? You need something that it's going to implement this interface. And so we'd have a class that implements I keyword bonus provider or whatever interface you've introduced. And instead of talking to the database, it just goes out and it has a dictionary and it returns this dictionary. Kind of more Lambda style syntax for this, but this is really the equivalent of that screenshot we saw earlier. And so by doing this, our tests, if you can provide an I keyword bonus provider to that method, you can now test it without needing a database. So your tests are now quicker and they're less brittle. So if your data changes, if your database goes offline, your tests are still passing, and you now have complete control over what those keywords are, and you can write your tests against that. So you're spending less time maintaining your tests over time, which is cool. This is really related to the principle of inversion of control, and it's a related term, dependency injection. These are some of the terms I hate the most in software engineering because they're kind of simple concepts with really scary labels that are actually very accurate, but it's very scary for someone who doesn't understand them yet. And I kind of resent that. But naming things is hard. But imagine a light bulb. If I'm going out and I'm buying a lamp, that lamp has a socket, and I can screw in a standard light bulb, an energy efficient light bulb, a light bulb with a dimmer, maybe a floodlight, whatever fits into that socket and can receive electricity. I can even put in a disco ball with the right adapter on it. The lamp doesn't need to care about the specific implementation of the light bulb, just as long as it fits in the socket and I can provide electricity to it. So this is inversion of control. So the lamp no longer needs to care about the specific version, it gets it from something else. And the way it gets it is typically called dependency injection. We have dependency injection built into ASP.NET Core, which is awesome, but not everything comes with dependency injection built into it. And so for those things, if you wanted to add something else or something with a little bit more features than the default container that Microsoft gives us, there's a popular library out there called AutoFac. So we can use AutoFac to get dependency injection and IOC, inversion of control support for other types of applications beyond just ASP.NET. And if we really like it, we can actually replace ASP.NET to use AutoFac. But with AutoFac, we have an iContainer. And the iContainer is just this magic object that we can say, hey, I need something of this type. Do you know about it? And you say you do this by calling container.resolve, and then you give it the type that you're looking for. Like, hey, dependency injection container, I need an I keyword bonus provider. Please give me the one that you have configured, and I'll be able to work with it. And if you've configured it properly, it gets out the SQL Server keyword bonus provider, or the mock testing keyword bonus provider, or something like that. If you haven't configured it, you get an exception and you feel shame, and then you fix it at development time. So that's sort of how that works from consuming it perspective. We configure it by using something called a container builder. So we create a new container builder, and then we say, hey, I want to register a new instance. Whenever you see an I keyword bonus provider, I want you to use this specific version. And what you can do is you can create a different container for production, like for your application running in the wild, and a different one for your tests, and maybe even different ones for different types of tests if they want each test to behave a little bit differently. And so this lets you kind of tweak your application and make it a little bit more maintainable, decouple things from external APIs or databases or email senders or whatever you might have. So this helps you test your application, and you call .build to actually generate the container when you're ready. So that's AutoFac, and many other types of dependency injection containers work just like this, just with different syntax. Kind of related to this is a library called mock, or mock-u. I like to call it mock because it's more descriptive of what it is. When you have a lot of interfaces and a lot of tests, you might often have a lot of little small classes that implement these interfaces. Mock says, hey, I can automatically create a dynamic class that will behave to match this interface. You just need to tell me what interface it is and how to configure the class's behavior. That's all you need to do. Syntax for this is a little scary, but the capabilities are pretty cool. So with mock, you say, hey, I want to match this particular interface, and I'm going to set up the behavior of each method that I care about. So I'm going to say, hey, whenever you see the load keyword bonus method, whenever that method is called, I want you to return a specific dictionary that looks like this. So if your resume contains the word attendee, that's 50 points. I don't know why you'd have that rule, but I don't know. It's brief, I guess. So we can set up any number of properties or methods on this interface and just really configure its behavior. We can even make it act differently based on the types of parameters that are going into the method. This is a simple example with no parameters, but like really complex examples can be pages and pages of code, which makes mock code kind of nasty to maintain as it grows over size. So you tend to put it in a small area and try not to think about it too much. When you finally want to get the instance out of it, you can call mock.object, and that actually generates your I keyword bonus provider, and you can use it anywhere that you would need an I keyword bonus provider. You don't need to use mock. If you don't like this, if this makes you and your team throw up, don't use it. But if you want to avoid writing a lot of small little classes, mock's great for that. But mock also gives you a little extra. It gives us the ability to do .verify on this. So we can verify the behavior of our class. So not only are we now asserting the correct result is coming out, but we are verifying the behavior of that method. So I'm verifying that the load keyword bonus method was called exactly one time. If I didn't call it, or if it was called twice or more, the test fails. People have kind of mixed opinions on whether this is good practice or not. Some people say that the only thing we should verify is the thing coming out of it. We shouldn't be verifying the behavior of that method. And other people say, hey, this lets me test more things. Do what works for you and your team. I like to avoid mock whenever I can, just because simple is often better, but sometimes you need the extra power, and mock's there for that. Finally, on the database topic, if you happen to be using Entity Framework, there's a really, really simple way. The clickbait way of saying this is there's one simple trick to testing your Entity Framework code, and that's to use this use in-memory database, and you can give it a name as well. So you say, hey, when I'm configuring my Entity Framework context for my unit test, I want to use an in-memory database. And then I'm going to go in and I'm going to add all the data that I need for my tests. So it's basically going to be an empty database that doesn't have a database. It's not making network calls, it's not making disk calls, it's just storing them in the computer's memory for the purpose of the unit test. And I can configure everything I need to, and when I'm ready, I hit save changes, and I pass along my context to something else, and that code is just working with an entity framework context, and it has no idea it's not talking to the real database at all. Nice and simple way of setting up your code to work with unit testing if you're using entity framework. So really something to consider if you're doing that. So now that we've talked about improving our testability and the basics of pinning down the application's current behavior, let's talk about some ways of just improving the quality of our tests, improving the readability and usability of our tests. Probably the #1 library that I always install whenever I'm creating a new unit test project. First of all, I will typically install in unit because I like it a little bit more than XUnit. But secondly, the first thing I do is I install a library called Should-ly. Should-ly has a much more popular big brother called fluent assertions, but they both do about the same thing. Instead of saying assert are equal expected comma actual, which sort of reads like a Yoda statement of some form, you can use extension methods to have really readable assertions. So I can say, hey, the results score should be really high. The resulting resume should not be null. The resume should be this specific resume. We should have, the resume should have a count of less than 1 job. The syntax is very similar between these two. I tend to prefer Should-ly just because I like the way it reads a little bit more. But fluent assertions is very, very popular, and it can do the same things and then more. So very good libraries to consider adding to your project because your test code does matter, and being able to read it and read it quickly, it really brings out your tests a little bit more in my experience. So #1 library I add every project, Should-ly. It's a really simple thing, but I love it. In the spirit of keeping your tests simple, one of the things you can do is add a library called AutoFixture. An AutoFixture is really good at creating objects. It's really good at creating objects and populating them with data that looks approximately correct. This is good for when you need an object of a specific type and you only need to customize a couple things of it. Like you can use this fixture.create to create a new instance of a resume, and then you customize the things on that resume that you care about. And it'll actually generate something that looks a lot like this. It uses reflection to look over each field or each property on that class, and it populates it with a value appropriate for that type. So here we have a description. So it says, okay, well, it's a string, so let's give it a string starting with description and then a random GUID after that. Oh, months and job, that's a number. Okay, here's a random number. And you can actually customize the way that AutoFixture builds these values based on the type of data or the name of the property or whatever. So you can do a lot of really complex stuff with AutoFixture to sort of mock out your tests. And that really can help focus people in on the stuff about your tests that actually matters. So kind of on that note, test code should matter as much or more as production code. And it doesn't always. But one of the things that we can do to help with that is make sure we're refactoring our tests. Anytime I see a unit test get too long, I am looking to pull out new methods. I'm looking to introduce a base class. So you can imagine a resume processing application. You're going to have a lot of stuff that processes resumes, right? And so you generate a base class with an analyze method, and you just call that. And the thing that matters is typically what do you pass into it, right? You might have some specific classes that some specific tests for the various components that go into that analyze thing. But this lets you focus more on the actual contents of your tests. So treat your tests with a lot of polish because it really helps you out in the long run. It helps people understand your code a little bit more. This is actually a bad example of this because I don't feel like this test is very descriptive of any particular business rule, but I ran out of time. So sorry about that. But refactor your tests because it really matters. And in addition to readability, if you need to update the way that something works, you can now update it in one place in your test, and you're spending less time maintaining your tests, which is always good. So let's talk about refactoring because we got a big old ball of mud. Now, remember, refactoring is changing the form of something without changing its behavior, right? So ideally, we are not going to be introducing any bugs by cleaning up legacy code. And in fact, when you start introducing bugs by cleaning up legacy code, that's when people tell you you need to stop doing that. So it's really important to not introduce bugs when cleaning up legacy code, because everybody's got legacy code and it's only going to pile up more. So it's really important to be able to effectively and as risk-free as possible clean up that code. So typically when you're deploying software, you have some piece of code, which I'm calling client here. It's calling your legacy routine, some routine that you really wish was better, some method or series of classes. And you might say, hey, let's clean up this thing. It's the worst thing in our project. Let's clean it up. Let's put it in the new release. And you release your software and your old routine's gone, the new routine's present, everything's great. You've done everything you can to test it and it hits production and you all go out and party because this thing you hated is now gone from your code. Until the breadth of the test data from all your users hits this new routine, and you see, oh, well, we didn't test this kind of a scenario. Oh, we didn't consider data like Joe's, and you need to either really quickly revert or patch your code. And when that happens, people usually want an explanation of what went wrong. Why were there these bugs? And as an organization, you become more and more risk averse from trying to clean up your legacy code. It's very important to be able to clean that up. And so you want to try to avoid this kind of a scenario because you only get to do it a certain number of times before you can't pay down your debt, and you need to pay down that debt. So one of the things you can do to make this a little bit better is using something called a feature flag. A feature flag is just some sort of a configuration thing stored in a file, a database, configuration settings, some external API potentially, but it has some sort of a flag like, hey, should we use the new version of the code or the old version of the code? And you've deployed both of them, but this flag tells it which one to use. This is nice because if you determine there's an error, you can really quickly switch off your new logic and go back to the old logic. Now you need to test this swap because bugs can occur either way. And so it's one more thing you need to test as you're building your application. But it gives you a nice quick circuit breaker to revert to an old version that works well. There's a lot of different libraries out there for working with feature flags. A nice paid one is Launch Darkly, but a good free one, the one that I like the most, is called Feature Toggle. And the code for it looks weird, but there's a reason I like it even though the code looks weird. So with Feature Toggle, it uses classes to define features. So things that we can configure on or off. And it's got things like date-based things or percentage of time-based things. I'm going to talk about the simple cases here. A simple feature toggle, let's say, hey, should we use the new resume analyzer or the old resume analyzer? We inherit from it. And then we can have some other piece of code say, hey, I need a resume analyzer. Should I use the new one or should I use the old one? And you can look at line 20, and this is a really weird line where we're saying, hey, I want to create a new instance of this feature, and then I want to check to see if the feature is enabled. And when we're checking to see if the feature is enabled, it's actually reading it from your configuration file. So here's an app settings.json file that has a feature toggle section with a use new analyzer configuration option, which can be either on or off. And there's a number of different ways of feeding settings into feature toggle as well. So it doesn't have to be this type of a setting. The reason I like this, as weird as this logic is because it removes my ability to make a mistake. If I made a typo here and I misspelled analyzer, as soon as I launch the code in development, I'm getting an error. If I made a typo here or here and here, well, my code doesn't compile. So this is the reason I like this is it takes the human error out of the equation at the cost of some slightly weird syntax, such as empty classes or this line 20 here. So that's an option to consider if you want to look at feature toggles. Another approach that people have often with releasing new features or fixes is to have kind of a beta program, and people can either opt in to a beta channel or they can sort of silently be opted in, where a percentage of your users get diverted to using the new routine. And this can help protect against failures in this new routine, because only a small percentage of your users are encountering it, and maybe they opted in to begin with. I don't like this as much, because if users opted in on beta stuff, they don't always use it to the same degree that they use like normal stuff. Additionally, if something goes wrong, the user still sees it, and that's what we're trying to avoid. And so I actually discovered this library from I think it was a Jason Roberts course on Pluralsight, but it's called scientist.net, and I get teased a lot about how much I like this library because I talk about it a lot. But scientist.net is based on the GitHub project of Scientist, which is actually run by GitHub. It's not like somebody's on GitHub, it's by them. But scientist.net is the .NET flavor of Scientist. And Scientist basically says, hey, I'm going to run an experiment. So you put Scientist in your code and you configure your experiment. And the calling code calls out to Scientist and says, hey, I want to run an experiment. And Scientist says, cool. I've got a legacy version and a new version. And it's going to call out to both pieces of your code. And the results are going to go back to Scientist, right? And here's the cool thing. Only the result of the legacy version goes back to the user. So if there's an error in the new version, the user has no idea. They never see it. It doesn't impact them whatsoever. The reason this is helpful is because Scientist takes all of its results and it pushes them to something called a result publisher. So you can take your mismatches where the legacy routine and the new routine handled something differently, or the new one errored on something, and you can store them into your result publisher. And that will send an email or store it in a database or whatever you wanted to do. It's just an interface. So you implement whatever result publisher you want. And then your development team can take a look at the error at their convenience, because this is not pressing, because nobody's ever seeing this error. And you can take a look and say, okay, well, we forgot about this specific case. And you can do another release. And you verify, okay, well, the new routine is actually working fine. We're not getting any errors from it. We think we're probably good. And once you're confident in your data, and you're confident that your users' data, that the data is working with the users' types of data, you can do another release, get rid of scientist.net, get rid of your legacy code, and everything is happy. So that's scientist.net. I really like it. You can't use it for everything. For example, if you have code that inserts into a database or modifies a database or deletes something or sends an email, you need to kind of extract that code into something else and have your client then call out to that. So you don't want to have any side effects in either one of these things. You just want to have some complex calculations. So look, you can't use Scientist everywhere, but in really critical cases, you can absolutely use it, and it's fantastic. So the code for Scientist is interesting. You call scientist.science, so like, hey, we're going to do science. I want to run an experiment that's going to return a type of whatever. In this case, it's a class I created called analysis results, but it could be whatever type you need it to be. You give it a name for the experiment. Here it's just the method name that called this method. And then it takes in a kind of an arrow function to configure your experiment. And you need 3 things at least. You can configure a lot more, but you need to tell it what legacy version to use, which is just an action that it can call. You tell it 1 or more experimental versions to try, and this is the kind of your new version. And then you tell it how to compare the results. And that's all it needs to run an experiment and see if the experiment succeeded or failed. So that's really cool. I've used this to clean up some old systems and to really bring quality to an application that desperately needed it, and do it in a safe and controlled manner. But I was initially hesitant to put this thing out in production. And what I found was that Scientist actually can really work well even just in unit tests. So I can take my existing tests and I can run a science experiment on them and run the legacy routine and the new routine and compare the results. And if they don't match, I'll fail the test. So that was my first foray with Scientist, is using it in the context of just unit testing. And once I was confident in it, I put it out into production. So a little funny that I was hesitant to put a library about reducing risk into production, but that's just me, I guess. So let's take a look at how we configure this result publisher, because it's a pretty important part of Scientist. So when we are configuring scientist, we need to give it a result publisher. So this line 15 here says scientist.resultPublisher. So your result publisher is this instance. And here I have it using a throw if mismatched publisher. This is a simple one that I created to fail unit tests if there was a mismatch. What this looks like is the interface is a little scary, but that's okay. It implements an iResult publisher, which just has a task called publish that takes in a type and a clean type, which you don't need to worry about what these are. That's kind of a scientist implementation detail they sort of inflict on you. But you're working with a result, and all you need to worry about is you can loop over mismatched observations, so anything that didn't match, and you can do whatever you want to do with it. In this case, I'm just writing it out to the console. And then I'm essentially just failing my tests because this is a result publisher intended to be used for unit tests. Scientist actually now has a way of using this in unit testing context without having to write your own result publisher. But I think this is still helpful to show you just what a result publisher might look like. But you can imagine taking these observations and writing them to a database or sending an email or creating a Jira ticket or something like that using an API. It can be whatever you need it to be, but it's pretty cool. So that's Scientist. I definitely encourage you to check it out if you think it might match your projects. And it's available in all sorts of different languages too. So now that we've gotten our tests working pretty well, let's take a look at how some ways we can expand the scale of our tests and write more tests and enable other people to write more tests. So one of the reasons I like InUnit so much is it gives us the ability to write parameterized unit tests. And parameterized unit tests are unit tests that take in parameters, right? So instead of this being one unit test now, this is now 3 unit tests where I have 3 different inline data statements, and each one of these is a test case. So when I run this in my test runner, it's going to call it once with a number of months of 1 and an expected score of 1. And it's going to go all the way through, and it's going to pass or fail. It's going to run it again with 3 and 3 and 10 and 10. And if I ever think of another case I care about, I can just add another line here. The alternative to this is I'd have to duplicate this method 3 times. And it'd be less apparent, what's different about each one, at just a kind of a casual glance. It'd also be more work to maintain my tests. So I really, really, really like InUnit and MS Test's ability to have parameterized unit tests. I think that's fantastic. Another thing you can do is you can actually give it kind of like a generator. So instead of having to say, hey, I want these 3 tests, I can say, hey, there's a lot of tests. I got a class that tells you exactly what tests to use. You give it a class data attribute. You say, hey, I want you to create an instance of integer range generator, which is a class I made up. I'll show you in a second. And it's going to provide you the values for these parameters, right? And so the integer range generator, in this case, it's almost a joke, kind of a class, but it implements IEnumerable of object array, and it has a getEnumerator method. And each time it's looping through 50 times from 0 to 49, and it's yielding a new object array. And that represents the parameters to pass into the months here. So this could be multiple things. Here, I'm just giving it the number of months. Code's kind of ugly to look at, unfortunately, but it's powerful. I actually have used this as a little bit of an April Fool's joke a couple years ago. I had a yearly goal set to help a legacy project hit a certain number of unit tests by the end of the year. It's a horrible thing to measure, but we don't have a lot of things to measure. And so I real quickly wrote up a range generator and built 50,000 unit tests and showed it to my boss and say, hey, do I get a raise now? And he said no, sadly. But then I went around and I beat the goal anyway in the normal manner. But it was a fun way to mess with him a little bit and just show him that numbers aren't everything. But these are really powerful, and there's a lot more things you can do, like using spreadsheets, files, databases, things like that. While we're talking about just expanding the types of things we can do, often you don't want randomness in your test cases, but sometimes you might. Sometimes you might say, like, we theorize that there might be some some cases where this might not work. And you can use a library like Bogus to generate sort of random test data. Bogus lets you generate very specific types of data like addresses, zip codes, numbers, social security numbers, phone numbers, things like that. Very specific types of things. It's actually really good to use for prototyping like view models and stuff like that when you're just building an application. But you create a new instance of Faker, and then you can just call I want a name and give me a full name instead of or a first name or a last name or something like that. I want a company, give me a company name or company address or slogan or website or something like that. And then you have fun stuff like hacker names and the like. I think there's actually paid tiers you can go to where you can actually get even more varieties of bogus data. But it's a pretty cool thing to do in a kind of a controlled scenario. And you can do, of course, random number generation as well. If you are relying on random data for your unit tests and you have a test failure, you need to write a specific test for that thing that failed, because you may never see that random number or random piece of data again. So this is good for maybe discovering some things your application won't pass on, but you need to immortalize those things in very specific tests when they do show up. I'm not sure I like random data in unit tests, but it does have a place in some scenarios. If you want your business analysts or quality assurance professionals or product owners to be able to provide tests for you without having to know code, you can rely on something called behavior-driven development, or BDD, and a library called SpecFlow. And this relies on something called Gherkin syntax to describe scenarios. So it's sort of scenario-given testing or based testing. So here we define as feature, which is kind of a set of scenarios, and we give it some sort of a text, some just general descriptive text. Doesn't matter, it's almost like a comment. And we can give individual tests kind of like tags. So here I'm relating everything here to scoring. And then we give it a scenario. This is basically the name of your test. So I'm calling this test months and job. And then I've got given, when, and then. And these are Gherkin keywords. I'm saying given a resume, when the candidate has held the job for 14 months, then their score should be 14. This is the kind of a sentence or set of phrases anyway that a product owner or a business analyst or somebody like that can generate pretty easily. And they can give you these things, and you can say, okay, well, now I need to implement some code to interpret this. And your code for that, like say, given a resume, I'm gonna make a method on a small like test context class. And it's going to take in this given attribute, so which has a regex next to it, and say if you see a given that's associated with this pattern, like it matches this pattern here, I want you to call this method, and it's actually modifying state on this class. So it's going to actually create the resume, and now you can have similar things for the and that matches this given up here, but you can have similar things for the when and the then. And so you can say, hey, when the candidate has held a job for months, so we have a when attribute here and some sort of regex, and note that we have a matcher here. So the number actually gets passed in as a parameter here for months. And then we can basically create some piece of data and manipulate our existing resume. And then the then is typically for assertions, and it follows about the same pattern. And you're just writing your code. And at the very bottom here, I've got this assertion. So I'm saying given, when, then, and then will actually pass or fail your test. So you're giving somebody else the ability to write tests in human English that either take advantage of existing patterns like this or ones that you write as you're developing the features or implementing a fix. And as a result, over time, you sort of build up a library of tests that look like this, and your QA and your BA and your product owners can write tests that you can then just quickly incorporate as you're building out your features, and you have them to rely on, and it actually documents things in plain English, and it just runs like a unit test, which is really cool. So that's behavior-driven development in a nutshell, and it's really cool. So that's the core of the talk. I think the talk about tools and processes is important. So I want to talk about a couple other ones that have made a difference to me personally. in the hopes that you might benefit from them. So you might have noticed these little green dots at the left edge of my Visual Studio instance or screenshots. These little green dots represent part of the InCrunch plugin for Visual Studio. And InCrunch is something that just automatically runs your tests in as efficient manner as it can detect in the background as you're modifying your code. So as your code is changing, it kind of shadow copies things around, recompiles what it needs to, and reruns your tests. And you can still keep on writing your code, and you note the greens and the yellows and the whites and the reds appearing as you're writing your code. So you can really quickly, even without having to build and run your code, see if you're breaking things, which is just weird. Like it's a really weird experience. It's distracting for some, but it's really helpful too, and it gives you kind of a nice indication that you're making progress. So you see the passing tests on the left. If they were failing, you'd see red. But you also get a little bit of a performance indication. So this one up here in the upper left is a little bit yellow, and that just means it takes a little bit longer of a time. And that's because this load keyword bonuses that it's calling, that was actually talking to the database. And you'll notice these white ones down here, these are just code that no tests are calling. So this points out areas of code coverage that you're missing right now. So that's InCrunch. It's a paid tool, but it's pretty cool. So it might make sense for you to use it. You can check out a free trial and see if it improves your quality, or if it helps motivate you, or if it's a distraction. I also think code reviews are a phenomenal way of maintaining your code quality. Even if you have nobody to review your code, just creating a merge request and taking a look at the diff and asking yourself these questions and looking over things and saying, okay, oh, I didn't even mean to commit that, or oh, I forgot about this, and what about that? Knowing that your code is going to get reviewed by somebody, or you're going to be forced to look at it yourself, is a really good motivator to help you test it as you're running along. I like to encourage a testing process where I make passes over the code. So the first time through, I'm looking over the code to see, okay, what's in here? What areas were modified? High level, what are we doing? Second pass, I might say, okay, did they think of X, Y, and Z? Did they think of this? What about this other feature? How does that relate to this other feature? Then I'm looking at things like, okay, is this a security risk? Is there any sort of a SQL injection vulnerability issue here? Something like that. And I'm like, okay, well, what about performance? And I'll make multiple passes over the same code time and time again, each with a different theme on things. So I think code reviews are really helpful, but you need to have a very good culture around code reviews, and they need to be a healthy and productive thing in your organization, which can be hard to do in some cases. Another thing I like is automated code analysis. So you can use a tool like SonarQube or the hosted version called Sonar Cloud, and then that will just sort of automatically analyze your code against known good standards for issues. And so SonarQube is going to go through and it's going to say, hey, you're not disposing this iDisposable thing over here, or you have a task over here and some async code that's returning void. You should be returning a task. It's going to help you spot the code smells and issues, and it's going to track their trends up and down over the life of your project, and as well as what areas and what types of things there are. This can be really helpful for helping you illustrate to somebody else, like, hey, I really need to refactor this part of our code. We have a lot of quality issues around here. We got a lot of issues here, and you can even write your own rules for this kind of thing. This can also be helpful for saying, okay, well, people keep making these mistakes. Let's talk to people individually about this in as gentle way as we can, because we keep seeing these same mistakes occurring. Getting back a little bit to code reviews, one of the things I like to encourage is a test plan. So whenever I'm starting to work on something, the first thing I do is I start by writing out a test plan. How do I verify that this is going to be correct? How do I verify that I didn't break anything in a related area as I'm going in to do this? And I'm just listing out things in Notepad typically, like single sentence. You should still be able to save a user. When I go to user details, it should not error, something like that, right? And as I'm modifying my code, as I think of new cases that might be needed based on the things I'm modifying, I'm adding them to my list. And then before I pass this on to code review or quality assurance, I'm going through my list of tests and I'm verifying that each one of these things I'm meeting the needs of my test. But beyond that, I'm actually sharing my test plan. Okay, hey, here's how I want you to review my code. Here's how I tested it. I actually became known for not accepting pull requests from people unless they had a sentence in there about how they personally tested it and ensured that it worked. And it's actually amazing what that did for quality. And it could be something like, hey, I opened it up in a browser and I banged on it and I did X, Y, and Z. It doesn't have to be a lot, but I want people to think about every change and to have some sort of a thing. And I also will then give the test plan to quality assurance. And they'll say, oh, well, this is how you tested it? Well, cool. I tested it this way, and I also thought of these other cases. Did you think about these things? And it actually kind of builds this relationship between development and QA over time, which is really, really helpful. And they can teach me about things that I missed, and I can teach them about some of the risks associated with my code based on the areas I changed. And you get better and better quality in everybody over time. It's really cool. So in conclusion, start by building a safety net for yourself, using the right tools to make sure that you're not going to modify things that you're not meaning to modify. Improve your ability to test your application, typically at the database level, but all sorts of types of things can be blockers to testing. Improve the quality of your tests, because your test code really matters, and it should be valuable documentation of the behavior of your system. Go into your code and just refactor it, make it clean, because you got to live there. Like, we all think that we're going to rewrite our systems, and it always takes longer to do, or we keep pushing these projects off. And so ultimately it never happens, or we rewrite it and the new version's buggy because we needed to fit the time allowed for it. And then finally, expand your tests by allowing other people to write your tests easily, or make it easier to add new cases without introducing duplication. One final plug for my employer. If you want to learn more about Tech Elevator, if you want to hire some of our grads, we actually have new classes graduating tomorrow, which I'm very excited about. Talk to Rita, Rita at techelevator.com. She can hook you up with whoever you'd like to talk to, whether from admissions or a hiring perspective. But I work here because I love the quality of our graduates, and it's what's made me be looking at Tech Elevator for years now. Thank you again, GlugNet, for having me. I have these slides available. That's actually an old URL. The version in chat is the better one to look at. I also put it on the meetup. Here's my information for Twitter and LinkedIn. And I've written about most of the things I've talked about and more on killalldefects.com. I don't update that as much anymore, but I have a lot of topics on there related to software quality. So check it out. What questions do we have?
Hi, this is Joe.
Hey, Joe.
One of the things in testing that seems to always come up when we start talking about unit testing, is particularly with people who have not done a lot of it, is database testing. We've got a SQL Server.
Yep.
You can mock the database, as you mentioned, but then you're not testing the database, you're testing the mock.
That's true.
So what do you recommend as best practice, or better than average practice, for testing SQL Server database or Oracle SQL database, whatever you're connecting to?
So I don't have a slide for it, but there's a concept of a testing pyramid where you have a lot of unit tests at the base, and then you have some kind of component tests, and then integration tests, and then system tests. So you want a lot of tests that don't cover the database, but you're going to want some integration tests that do. So you're going to have a few slower integration tests that you run maybe less frequently, but you still run them, that verify that you haven't been introducing issues to your database. When you are doing database tests, often one of the things you can do is you can seed the database with good values in it by running a script before you run your tests. You can also run all your code in a transaction and roll the transaction back. That can be a little invasive depending on how your code works, but that's an option. In general, I think it's very healthy to have some form of integration test, whether through formal unit tests in C# or through something like Selenium or something else. I also feel like every user-facing feature should be tested manually. Maybe not regularly, but as you're adding a new code, you got to be clicking on the buttons. It's not good enough to say the test passes, therefore the feature is good. You got to go in and check it. This is something I really try to drill into our students, because by the end of our program, they're so used to unit tests that when they get into web development, they don't even launch their Vue.js app to see if it runs without errors. Like, no, you got to launch it at least once. And
it's a nice problem to have, right? When they trust your unit test that much.
Yeah. And JavaScript testing, that's a whole different world too. Like there's so many things out there for testability in JavaScript. Good question.
Hey, Matt, you talked about test-driven development and behavior-driven development.
Sure.
And I'm just curious to hear your thoughts around, is there one approach that is gaining popularity lately, or out of the two, which one is the most optimal approach, you would say?
So they're for different people. I view behavior-driven development as a way of coordinating with QA and product management and things like that, business analysts. Versus a unit test in test-driven development is very good for me as a developer as I'm building something. So I'm almost the primary beneficiary of a test-driven development, but a BDD is really good for kind of automating acceptance tests almost, if that makes sense.
Gotcha. Yep.
Yeah. See a question in chat. Do we need to test the test tools? If I'm reading that right. No, I don't think you do. Generally, you're going to know if your test tools become unreliable because you're going to see all sorts of weird stuff, and then you look for something else. I like using JetBrains. Their test runner is actually really good compared to Visual Studio's built-in ones. Nice little segue to our raffle in a minute. But in general, you don't need to test the framework. You don't need to test the test tools because that's somebody else's responsibility. And if they messed up on that, start thinking about another vendor. It's my advice. But one of the first tests I saw from a junior fellow on my team was he was creating a new list. He was adding something to that list in the act step, and then he was asserting the count of the list. It's like, hey, buddy, you're testing .NET here. I don't think we really need this list test in our code. I applauded the effort though. But we want to test the things that we think are going to break most often. If you think it's going to break, have a plan for testing that it works, whether it's a manual test or something else.
Matt, I have another one.
Yeah.
So what's your feelings on code coverage? Should it be 100%, 80%, 90%? Do you how extensively do you test a single routine in order before you're comfortable that you've tested it well enough?
I think code coverage is great at being a metric that can be measured. I think it's something that we can measure, and it's somewhat informative. But I can write a unit test that verifies the application doesn't crash, and it will look like I've covered 60% of my code or more, and that's not very helpful. That code coverage percentage that looks like a lie at that point. I think it's helpful telling us which lines aren't covered, but I don't think you need to have 100% coverage. I don't need to write a test that's going to verify that a argument null exception is thrown if I pass a null into a method. I care a lot more about cyclomatic complexity than I care about code coverage. Cyclomatic complexity is the number of unique paths through a method, which talks about how difficult to understand and how difficult to test a given method might be. Another one of those scary terms. I think that as long as you're at, I don't know, 50, 60% code coverage, you're probably in a good place. Trying to shoot for something past 80% is usually a waste of time in my experience. But that's my opinion.
So reducing the cyclomatic complexity is part of that refactoring
Yes.
stage that you would go through.
Yes, absolutely, yeah.
Okay. And one more, I think, unless I think of something else. What about private methods? Private methods can be difficult to test because most of the testing tools require public methods.
Yeah. Private methods is like an implementation detail. You're not writing a test typically to cover every line of code in a method. So why would you write a test to cover every method in a class? If you're just testing the behavior of a class, that's fine. In fact, by not testing private methods, you are freeing up the class implementation to change down the road, and that's healthy. So test the side effects of your public methods, test the behavior of the public methods, and that's a good policy. You can use stuff like reflection and the like, but that's just getting into garbage you don't need to worry about.
Right. So focus on the behavior, not the number of lines.
Yes.
Okay. All right, that's good advice.
Mm-hmm.
I've got a question, Matt.
Yeah.
So at my current employer, we're in the situation where our system is a customization of some software we bought from a vendor that they customized for us. And so basically we're sitting on top of a number of base classes that we do not have access to. We have the DLLs, but we don't have the source code. So we've always talked about, well, how do we unit test this, knowing that we are looking at the tip of the iceberg code-wise? Wonder if you have any advice on that scenario.
I mean, I don't really. The same stuff is gonna hold over, right? You're gonna test the public methods of it. If you don't trust your vendor, yeah, maybe write some unit tests around it. I've been in a scenario where I had a component vendor for some WPF and Silverlight controls, and it's a while back now. And every time we updated, something always broke, and so we came up with kind of a manual suite of things to test after we updated, but we also came up with some automated user interface tests on some of the more nuanced bugs, like, hey, there tends to be a lot of weird issues around this particular area, so and it's hard to test, so let's just write some recorded unit tests around that. So it depends on what type of thing you're working with. If something's absolutely business critical and you don't think that you're going to notice it and you get an update, yeah, write a test around it. Especially if they don't have a good track record.
Yeah, and that's sort of the approach we took. We wrote a Selenium framework and utilized NUnit to drive some of the UIs and at least get a functional perspective that everything is working as we expected, even if we can't look at the code and say we're covering 50% of the code or whatever metric we're using.
Yep. Yeah, fun times. Sometimes you do stuff that you wish you didn't have to do, but you're doing it for self-defense purposes. Well, cool. I'm available on Twitter and at matt.eland@gmail.com if anybody wants to send me an email with a question later on. I'm going to turn this back over to you to do our closing ceremonies, etc. But thank you again for having me.
Thank you, Matt.
Thank you, Matt. Very good.
All right, so the link is in the chat for the feedback survey. I'll also send an email out with that. That will be open for 24 hours, so you get a little bit of time, but please fill that out. And don't forget about our giveaways. I think that's all I have. Joe, anything else?
Just mention that we're going to hang out for a little bit afterwards, so don't click leave quite so fast. If you want to just hang out and talk, discuss any issues, any concerns, any questions, general developer things, or even non-developer things, you are welcome to stay afterwards and just have a little social time.
Sounds good. Thank you, everybody, and hope you stick around for social time.